Good morning, all of you. Myself, Dr.K Viswanath Allamraju, Department of Mechanical Engineering, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today, we are going to study the topic of classification of materials. In the last class, we have studied the introduction of material science. And today, we are studying what is classification of materials. Before going to study the classification of materials, one has to know the properties. What is the property? What is the definition of property? How it will be useful in order to understand the various characteristics of the material. A property is nothing but whenever any material exposed to some external impetus, then what happens? There is some impulse will be exhibited by the material. Those exhibited impulses are known as that external stimuli, then it is called as property. So suppose if we consider there are some, suppose if we mechanically, if we understand that, suppose if we consider a specimen is subjected to forces, then what happens? It experiences a deformation. This external stimuli is the force for this case, and what it is exhibiting, the internality, that is deformation, is the response of the material. So property means very simple. Whenever any structure or any body or any material or any component are exposed to or being exposed to some external stimuli, then what happens? This material or this component or this structure responses, particular response manner, then those responses are called as properties of that particular component or structure. Now here, when mechanical component is exposed to or some load, then the response is that either bending stress or deformation. This deformation is the property of that material. So one more important point is that properties are made independent of material shape and size. That means properties are independent of geometry, of a structure, of a component. That's why based on this property, based on this definition, we can understand that based on this message, what is the meaning is that if you want to study properties of crankshaft, of a 4-stroke engine, of a 6-cylinder engine, of a 8-cylinder engine, if we want to study the property of that crankshaft material, then what we will do, we'll make it that material into a small, based on the standards sample size. Sample will be prepared and that sample will be tested. If you want to test tensile testing, tensile strength, if we want to find out the tensile strength of that particular material, then we have to use universal testing machine. And if you want to find out the hardness of a certain material, then what to do? We have to go for a hardness test rig. So there are various properties are there. That the properties are ductility, brittleness, hardness, malleability, tensile strength. These are all various mechanical properties of materials. So ductility, what is it? What is ductility? When the material is subject to a certain load, it will be deformed. Then it is known as ductility. And what is brittleness? When the material is subjected to particular load, then the material with very less deformation, it will be fractured. Failure takes place. Then that property is known as brittleness property. And what is malleability? When the material will be deformed under compressive load, then it is malleability. So like that, we'll understand various mechanical properties of materials and what are the importance of those materials. Without understanding those materials, we cannot optimize the particular component, particular material, unless and until we study those mechanical properties of materials. Now here, if we consider here, there is some virtually all important properties of solid materials may be grouped into 6 different categories. What are they? They are mechanical properties, electrical properties, thermal properties, and optical properties, and also finally deteriorative properties. So here, this is mechanical property and electrical properties. What mechanical properties so far I have discussed, such as ductility, brittleness, hardness, malleability, creep, fatigue, etc. So here electrical properties and thermal properties, magnetic, optical and deteriorative properties. Now let us begin with what are mechanical properties are. Here mechanical properties related to deformation to an applied load or force. Examples includes elastic modulus stiffness, that is strength and resistance to fracture. And what are the electrical properties? Here these electrical properties, that means the stimulus in this, the stimulus is for this electrical properties is an applied electric field. What is response of particular when electrical field occurs? The response is that electrical conductivity and dielectric constant. Whereas in thermal properties, the changes in temperature is the stimulus, that is the temperature gradient. And what are the examples? That thermal behavior includes thermal expansion and heat capacity are the responses. Now next, if you go for magnetic properties, the magnetic properties are the responses of a material. The magnetic properties, if you understand, the responses of a material to the application, the responses of the material to the application is that magnetic field, that is the response of a material to the application of a magnetic field is that the magnetic properties are magnetic susceptibility and magnetization. Coming to the picture of optical properties, in the optical properties, the stimulus is electromagnetic or light radiation. And what is that response? The response of the material is reflectivity or index of the refraction is the response or the responses. When the stimulus is electromagnetic field, then the response is refractivity or reflectivity or index of refraction or the optical properties. Coming to the deteriorative characteristics, this is what is the meaning of deteriorative characteristics. When the material is, the stimulus is here chemical reactivity, and what is response is corrosion, that is called corrosion resistance of metals. So thus we can understand the 6 categories of the properties. Once again, what is the property? When the material is exposed to certain external stimulus, then the material gives response for that external stimulus. That behavior, that responses, or those responses are called as, are known as properties of particular that materials. Now, if you understand in this figure, there are 3 materials are there. This is the transparent. So what is the transparent material? It's completely transparent. Another one is completely zero transparent. That zero transparent is nothing but opaque material. That is, light doesn't pass through that material. Whereas here translucent materials, that meaning that reflected light is transmitted through the disc. It will be transmitted partially. Whereas it is completely transparent. So light transmitted, okay, it is completely transparent, it's partial, and zero transparency. That zero transparent materials are known as opaque materials. So none of the light passes through it. Whereas the translucent materials, what happens? The translucent material, this is the translucent material. The translucent material means some of this reflected light is transmitted, some partially transmitted. Light is transmitted partially. Here completely, that is transparent. This is translucent. It is opaque, means zero. None of the light passes through it. Thus we can understand, comes into the category of optical properties. Now, what are the things required in order to understand the discipline of material science and engineering and their interrelationship? There are 4 components are required. Mainly 4 components are required. What are they? Number 1, processing of the materials. Number 2, structure. Number 3, properties. Number 4, performance. These are the 4 components are required. Suppose if you're studying the processing of materials, that also comes under material science, research of material science. If you're studying the structure of materials, yes, it also goes to material science branch. Next, properties of materials. It comes under to the category of discipline of material science and engineering. Whereas if you understand the performance of materials, this comes under performance. What is the performance meaning here? Optimization of particular property. If you want more tensile strength or if you want more compressive strength, or if you want more ductility, or if you want more brittleness, the way you want, if you want to optimize it, that is a performance. So that category also comes under the discipline of material science and engineering. So if you understand the interrelationship between, so what if you want to get optimizing better performance, what is required? Better properties are required. If you want better properties, the structure should be better. Then what if you want the structure should be better? What is required? Processing should be better. So the performance, if you are studying, it includes processing, structure, and properties. Whereas if you're studying only properties, then it includes two other categories such as processing and structure. If you want to study only structure, it includes the processing. If you only do it only research in processing, it doesn't include only one thing, one component, that is called processing component. So whenever we go for studying the performance of materials, that performance of materials component includes remaining three components such as processing, structure, properties. If you want to understand, very simple, PSPP. P for first letter for processing, second letter for S for structure, P for properties, and another P for performance. So this is a PSPP. So properties, structure, processing, structure, properties, and performance. So this is the PSPP. There is four components which are required in the discipline of material science and engineering. Let us go for classification of materials. There are mainly all materials are classified into four categories. What are they? Number one, metals. Number two, ceramics. Number three, polymers. Number four, and composites. So what are the metals are? The metals are aluminium, copper, steel, nickel, titanium, etc. So these are the examples for metals. Whereas here, what are the ceramics are? The examples for ceramics are clay, silicon glass, alumina, and quartz. And what are the polymers are? Polymers are nothing but plastics. That is polyvinyl chloride, that is PVC, Teflon, various plastics, glue, that is adhesives, and Kevlar. What are the composites are? There are various types of composites are there, but here I present here only three types of composites: wood, carbon fiber, resins, and concrete. But if you go for broad category of these composites, those are again natural fiber composites. Based on the matrix, it is again polymer matrix composites, that is a PMC, ceramic composites, and metal matrix composites, that is a ceramic CMCs. Again, that is based on the matrix. Again, three subcategories are there, but based on the natural fiber, based on the fibers, natural fiber and synthetic fibers. So thus we can understand the classification of various materials. Now we are going to understand the application of materials. So here, these are the familiar objects I'm going to show you here. I'm showing you, one is knife, another one is fork and scissors and coins, etc. So these are all made of metal alloys. So metals examples. So this is the silverware, fork, these are made of silvers. These are the scissors. These are scissors and coins, a gear, a wedding ring, and also nut and bolt. These are all examples for metals. Coming to ceramics. What are the ceramics are? Ceramic materials are bricks or comes under ceramics. This is also teacup. This is the teacup is ceramic material. A building brick is scissors. This is also made of ceramic here. There are two types of, you can make, scissors can be made of metals also and also ceramics. This is the floor title and a glass vase. These are all ceramic materials examples. Now coming to the polymeric. What is the polymeric materials are? This is the helmet. Again, plastic spoons. Small wheels. This is the plastic made of a plastic tin. These are the two dies and a lawn mower wheel. This is the lawn mower wheel, a plastic cup and rubber tire, and a plastic milk carton. This is what. These are the made of material polymeric. Now coming to the scale of, what is the scale in material science we are going to study. So there are various scales are there. Number one, atomic level. Number two, nano, micro, and macro level. These are the four levels. So when the atoms or when the particles are less than 10 power minus 10 meters, then the study is the atomic level study. And whereas nano level, it is less than 10 power minus 9 meters, and micro is 10 power minus 6 meters, and it is macro is above 10 power minus 3 meters. That means it is the between from 1 millimeter to more than meters. Then that study is the macro level study. These are the length scales, various length scales in the discipline of or in the branch of material science. Now, atomic structure, as I told you here, this is the different various bonds will be there. That is atomic ionic bond, covalent bond, metallic, and London dispersion forces. That is called van der Waals. So these are the atomic structure level. Now here nanostructure. As I told you here, it is the less than 10 power minus 9 meters. Then the scale, the study is the nano level scale study. That's called nanostructural materials. So what happens here? Length scale that pertains to clusters of atoms that make up small particles or material features. So some of the materials we have to study at nano level, some of the materials we have to study at atomic and macro and micro levels. So these are the various examples. So this is the microstructure. If you want to, this figure shows the microstructure of another material, some materials of a some here one car four-wheeler. So this is the micro level of structure. Now macrostructure, there is the X-rays. Macrostructure pertains to collective features and microstructure level. What will we study here? Cracks, grain flow, porosity are all examples of a macrostructure feature. This is a macrostructure. It is above or greater than 10 power minus 3 meters. So these are the various classes of metals as we have discussed it just now. The metals, MPCC, metals, polymers, ceramics and composites. These are the various examples related to various materials. So thus we can we can end the today's session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.